Thank you, everyone, for coming. I see a few more people showing up. That's great. My name's Andrew Phillips. I'm a product manager in GCP DevOps. That's the part of Google Cloud that worries about like local developer and software delivery tooling. And I want to be kind of really quick and efficient with my part of this presentation because I really want to tee up John over there, who's going to introduce himself. John Engelman from Target, who's going to talk about a really fascinating journey about building and why and how and lessons learned an application delivery platform. I'd like to kick it off a little bit, though, just by way of introduction, for setting the kind of stage for why it actually makes sense to think about this as a separate problem in the first place, especially in an enterprise context, and some of the lessons that we, from a Google perspective, can share in that area. We just said that, all right. Blah, the me slide, I mean, from a background perspective, I've been in this space for a really long time. I've been both a developer and a head of duct tape, AKA head of operations and a product manager and all these kind of things. So I've seen lots of pain from lots of different angles here. One of the things I did a lot of when I was a head of strategy in this space was I showed a slide like this. Every enterprise must have seen this slide 50 million times. It's the classic slide that says, if you don't find a way to speed up, you are going to go bankrupt. And there's lots of good data to back this up. And so it's a really genuine problem. And thus, I think it's legitimate that we all think about it. But by and large, people are convinced that this is genuinely an issue to look at. And what then tends to happen, and this is, I think, where an important lesson comes in, is that you start drawing a diagram like this, right? Oh, my software delivery pipeline. Got source code over here, got just a few things I need to do, and then I'm going to be in production. It kind of looks sort of simple and compelling, and you could imagine if you have a simple website with some code, that could sort of work. But of course, the reality, first of all, is that it's actually more of a tooling landscape that looks a little bit like this. And so it's an enormous integration game that you already start to have to play. And if you try to play that integration game all across the pipeline in one go, it's very quickly a boil the ocean type problem. And I think we all know how this goes wrong, and there's just too much to tackle to get this right. So I think an important lesson to start out with is that not just is there, there's a big challenge lying under this deceptively simple diagram, but I think there's another really important point, and that is conceptually thinking of it as this, let me just go back one. Oh, does this work? Can I go back? Thinking of it as this conceptually simple left to right, just do all the things diagram, obscures the fact that there's actually two related but different processes at work here. And so the way I draw this diagram now is a little bit more like this. I don't really use the terms CI and CD very much because they kind of imply automation and more automation. Instead, I talk about the developer feedback cycle and the application release cycle on the other side. And I find that framing helps me a lot because if you look at what we do as Google or what many other companies do, your developer feedback cycle, you want that to run every single time you propose or commit a code change. And if any of you heard the Cloud Build announcement, I'm sure a lot of you did, Google's doing a lot in this space to provide great tooling to make that really easy and really efficient. And this is all about speed and efficiency and getting great information back to your developers as quickly as possible. But then on the other side, you have the application release cycle, which maybe you want to do every time you commit a line of code, or maybe not. Maybe you do it weekly or every sprint or whatever. And here, there are many different triggers, and the goals are also somewhat different. You're typically not worried all that much about doing this as fast as possible. You're worried about doing it in a compliant way, in a way that prevents risk from creating problems for your organization, et cetera, et cetera, et cetera. Safe, compliance, all these kind of adjectives come into play. And if I zoom in a little bit more specifically on that second half of this pipeline, application release, what are actually three components from my perspective or from our perspective that are really important to think about here? Very often, if you think of it as a pure automation problem, you only really think about the middle one, application deployment, which is those steps that you need to take to get your bits and bytes actually into production. But there's two other very important parts that we see a lot of people recognizing at large scale. One is the simple notion of, how do I even understand what is running where? That's not a process problem. That's a problem of understanding your current state. And sure, if you have a single runtime in a single GCP project, that's not a big deal. But if you're doing multi-cluster, multi-cloud, maybe different types of runtimes, it starts to become a huge problem. And not only do you want to understand what's actually out there, you probably also want to act on it in certain limited ways. You want to roll back, you want to scale up, you want to scale down, you want to understand health, and so on. And then another aspect of the deployment process specifically, or the application release process, is that there's a bunch of kind of domain-specific best practices that are really important to implement in this area, and that ideally you would like tooling in this space to give you out of the box. Whether it's things like immutable infrastructure, or good support for rollbacks, or canary analysis, or all these other kind of things. Like everything else, they can all be scripted, but it's much, much better if you can provide this functionality out of the box. I'm not going to go through all of them. And then obviously from a perspective of what we know enterprises want, and indeed most developers and operations teams want, great to have all this functionality, but we want it to be secure. We ideally want it to be open, so it's extensible and understandable. We would like hybrid and multi-cloud support, and we wanted to support all the other 50,000 things you remember from that slide I showed a little earlier. Because, of course, we can't throw away everything we have. We need to leverage our existing investments, et cetera, et cetera, et cetera. So this is me teeing up Spinnaker here, effectively. This is an open source project, which was originally conceived, well, the predecessor version actually was conceived as Netflix's continuous delivery platform for this part of their life cycle. And it's now a very successful open source project used by, John will talk about how Target uses it, but used by Netflix and Google and many, many other companies. Obviously supports all the runtimes that we care about. Kubernetes, big topic here, but all the other ones that we know across multiple clouds. And there's a lot of people using it. I won't bore you with the logo slide. It's a nice one to look at later. Going back to the 4 key attributes that I talked about, one of them was open. And we find that very important for our customers, not just because it gives them flexibility in where and how they run it, but also because it gives companies' release and platform engineering teams the capability to tailor it to their needs and to match the requirements that every company comes up against and that are somewhat different in their contexts. So with that, let me hand it over to John, who will talk about exactly how Target solved this problem.
Good afternoon, everyone. I'm very excited to be up here talking about Target's journey and this path to today. My name is John Engelman. I'm a principal engineer with the Release and Runtime Engineering Group at Target, and I basically do what Andrew does as well, but for Target. I'm also a regular open source contributor. I've been working in kind of the build, automation, and deployment in cloud spaces for a number of years now. And prior to coming to Target, I was working as a consultant and doing this for everything from 10-person companies up to today, where I'm doing it for a Fortune 50 company in a number of different spaces. So before I get into how Target does this today, I want to give you a little bit of idea, and I want to reinforce some of what Andrew was saying just a little bit. So first of all, from my experience as a consultant, this journey is not unique to Target. This is the same path that I've seen many companies go on. I'm also not going to stand here and tell you the answer to this problem, right? Because there isn't one answer. I find that building platforms, and in particular this application delivery space, there's not a single solution, because the solutions have to be geared for your particular business and technical requirements, right? It's almost a very personal engineering problem space to have happen. Also, just simply everything Andrew said is right. When we started putting this talk together, it was very interesting how quickly our ideas coalesced around the same things. One of the issues that I see in the industry right now is that we have a tendency to refer to CI/CD as like a singular composite concept, right? I have a CI/CD tool, I'm doing CI/CD, etc. But as Andrew was saying, they are separate, right? So continuous integration is about modeling that software development cycle, how developers are getting feedback, how are we increasing velocity and increasing the quality of our code by decreasing that cycle time, right? And ultimately, the outcome of that cycle is that we're producing a deployable artifact that we consider good based on the information that we have today. So one of the things that we strive for is to get this automated code coverage that covers everything. And if anyone says that they're aiming and striving for 100% test coverage, that's great, and we should do that. But it's absolutely not required to be successful at continuous integration, right? And on the other side, continuous deployment is about that software delivery cycle, right? And here, the real purpose is to decrease the impact to customers of disruptive operational actions that we're taking on our application, right? And our outcome is to make available a new version of our software and be able to recover from any possible regressions that happen during that deployment. So in this sense, both of these actions are orchestrated workflows, but with very different requirements, right? And if you look at it, a CI workflow is very linear in general, where if an error occurs along that line, we basically say stop, right? Just stop, fail out, don't do anything more. And they're generally very short running. Whereas in continuous delivery, we have this very complex logic of what to do when we're rolling out, right? There's external forces acting that are telling us what to do next, and in a failure case, how do we recover from that? And these continuous delivery workflows can be very long running, anywhere from minutes to hours to days or even longer, depending on what type of system we're rolling out. So to summarize that, CI and CD really are two disparate ideas, and it doesn't imply that we're using a single tool to solve them. If you have a single tool that solves both those problems and it works for you, that's great, but we don't have to. So Target, and how are we solving some of these problems? So before I tell you what we're doing today and what we're going to be doing tomorrow, I got to tell you where we came from and what we were doing yesterday. So let's rewind the clock 5 years. So long before I joined Target, and we were a traditional enterprise organization, right? We had development teams, we had operations teams, and developers built code and threw that over the wall to operations teams that deployed it and monitored it and managed it. So very traditional workflow in that sense. Our delivery cycles were tied to business and financial calendars and all that stuff. And I think anytime that you look at a state of a system or a process or an organization, you have to, there are pros and cons to both those things, right? So one of the pros for this kind of traditional enterprise, even though most of us would say there's nothing pro about it, is that we did have decoupled development and delivery cycles. Now, it wasn't a great decoupling because we ended up in these large, big bang deliveries with intensive integration cycles and things like that. And we also got into that siloing of responsibilities, right? And when everyone thinks someone else is responsible, ultimately no one ends up being responsible. And that's really coming back to the TLDR, is just that we weren't doing DevOps yet, right? And this is a very common starting point for many, many enterprises or large organizations. So we knew we needed to change. And our developers actually kind of took that into their hand and started to organically grow the usage of Chef as a configuration automation tool within Target. This allowed them to reliably provision new servers in a very consistent manner. We were dropping our times of how long it took to get a server out there and running very, very quickly, from potentially weeks to hours. Right, so we started introducing some commonality to our processes. We were able to write some higher order tests and functions. We started sharing knowledge among our development teams about, what are the best practices for really doing this. But on the other side, we went from this decoupled cycle into now a process where we were conflating runtime configuration with application versions and application delivery. We were still, we're obviously still using mutable infrastructure, so things like rollback were very difficult. And because it grew organically and naturally out of the dev teams, there was no real guidance, right? So we started seeing some anti-patterns developing within the tooling and implementation that we had. So we knew we needed to provide some structure for our developers and users to encode these best practices. And one of those is that we shouldn't use a configuration management tool as a general purpose orchestrator, right? If we're just trying to automate, fluid tasks, there's probably better tools situated for that purpose. And finally, we knew we needed to model the actual deployment from the ground up and not just the runtime of the application. So after about a year of working with Chef in the organization, we started building a new internal tool called Houston. And Houston was an infrastructure management tool. So it was built around our native infrastructure provider APIs. It used their tooling. It still used Chef underneath the hood to provide runtime configuration. And it gave us a step to more closely model and automate more of what's needed to get an application out and running. And it further reduced that time. So we started introducing concepts such as infrastructure as code, deployment strategies to our development teams. We further reduced that time. But on the other side, we created a homegrown tool that offered no support out in the greater community. When our devs had an issue, they couldn't go to Stack Overflow or Google and find the answer to the problem. We couldn't source any work or additions to the tool from outside of Target, and not even from inside Target, because the code was so custom that just the team that built it was able to support it. And the biggest mistake that we made in Houston was that we introduced our own language to what an application deployment was. It had this idea of missions and orbits and things like that. And what we learned from that is that we had built this tool strictly from the vision of how are we going to automate and make infrastructure development easier and better, right? And that doesn't always work for developers, right? So we had this impedance mismatch, right? We had built a tool that was really, really good at managing automated infrastructure, but not so good at modeling an application itself. And we also learned that we just shouldn't try to create models and abstractions that don't convey what it is, right? You have to talk about your application deployments in a way that is linked to the practical concepts and features that they represent, right? So we don't call a dog an orange because it's a dog, not an orange, right? So we should call a server, or an application. So after about another year working with Houston, one of our engineers came in and said, "Hey, I've been playing around with this tool out of Netflix called Spinnaker to do some things, and I think it would help solve a lot of problems for us." And I'm not going to get into all the deep down nitty-gritty about Spinnaker. There's lots of resources out there. But ultimately, fundamentally, Spinnaker is an immutable infrastructure tool, right? It's built around those concepts of immutability. And this was a very seismic shift for our developers and our infrastructure to start thinking about. We had to rethink many, many parts of our platform, right? We had to rethink how we were getting runtime configuration and secrets. We had to rethink how we were packaging applications. So we needed to start small because there were going to be a lot of moving parts and a lot of things that we needed to change and fix. So we started with a small pilot group of dev teams that we knew could move and make changes as we found out and learned lessons and things like that. And as we started rolling this out and working with these pilot teams, we learned a lot about Spinnaker, right? Because no one had the experience with it yet. But we knew that Spinnaker's pipelines were very robust at modeling how we wanted to roll applications out to places. It gives you just about anything you need out of the box to do that. But we didn't use all of it all the time. Most of our development teams just simply need to get an application out, right? It's a stateless application. They need to bring up a new server group. They need to get traffic to it, and they need to shut down the old one. Right? So while Spinnaker has lots of ability to model complex workflows, we didn't necessarily need it all out of the gate. Where we did need it was to support our infrastructure teams. So things that weren't stateless applications, Elasticsearch, Kafka, Cassandra, things like this, where we needed a much more refined control in how we were deploying large clusters of things. And Spinnaker allowed us to do that. So not only did it solve the simple problem for us, it also allowed us to solve the difficult problems as well. So we did this pilot. We started seeing, we were able to get better visibility into our deployment footprints. We were getting better consistency. But our dev teams were starting to tell us, you're abstracting us too far away from the infrastructure. We want to be on the native, right on the API and things like that. And the biggest frustration that they gave us is, it's 3 years and you're giving us a third platform, right? So 3 years in a row, we've asked them to change. So they were getting a little bit frustrated on that. So we had to stop and ask ourselves, okay, do we do this? Do we push this across the whole organization? Was there enough value in doing it? And unsurprisingly, yes. If the answer to this was no, it'd be a very anticlimactic talk. Right, so if we look at the cost value of what Spinnaker brought us at the end was this simplification of the infrastructure. So the primitives that Spinnaker uses to talk about applications, such as server groups and clusters, model any type of application delivery really, really well. And then on top of that, it uses a naming-based pattern to correlate and aggregate infrastructure so that you get kind of an application graph of what belongs to an application. It also has a really, really good workflow orchestration engine. And if you've ever implemented a workflow engine of any kind, you know that they're hard. So Spinnaker's engine it's very scalable. It supports resuming in error conditions or even restarts of it. It's flexible, it's fast, and companies like Google and Netflix are using it to drive, giant deployments across their organizations. So we know it's battle tested and it works well. And finally, if you heard our CIO at the keynote yesterday morning, Target wants to support open source communities as much as possible. We leverage a lot of open source technology, and we want to contribute back to that. So Spinnaker, as an open source tool with backings of many companies, big and small, was a great place for us to get into that community. So we could leverage their knowledge, we could give back, we could participate in that whole thing. So we've decided to move on to Spinnaker at this point, and we have to figure out how do we move Spinnaker out into the rest of Target, right? The first part is we needed to add support for Target's private data centers. So Spinnaker ships with a number of cloud provider implementations, but not all of the ones that we use in our infrastructure were supported. So we put together a development team, and we joined them up in the Spinnaker community, and they were highly active. They collaborated with some other teams, and they started contributing back major implementations of Spinnaker's underlying code to support our infrastructure. We also had to roll out additional integration with other platforms that we have, such as Kubernetes and things like that. In order to facilitate this internally, we started organizing flash builds between development teams and our platform engineers to kind of sit with them and be embedded with them and move them onto these platforms. Because they were moving from some of them were moving from N-2 platforms from Chef into this, and let alone from the previous platform from Houston. So in the end, Target's topology looks something like this within our kind of our private data center and public cloud. We use Openstack for VM deployments. We use Kubernetes in our data center. We use Google Cloud Platform out on the edge. We use other providers on top of that as well. So we're using quite a few of the components inside of Spinnaker at any given time. And one of the things we learned is we probably should have stopped and rewound and thought about how we were doing things. Because you need to think about how you're going to be onboarding users and applications into Spinnaker. Because it's based on this static name, because it's based on a naming convention, and because you're dealing with immutable infrastructure, if you don't adhere to those patterns right out of the gate, you get into a position where you're having to move a lot of things later in order to make a better organization. If you're looking at running Spinnaker at scale, you also need to understand how Spinnaker's configuration works, what the different microservice components do, and how you're going to manage that configuration and roll out changes to your users. Because if you're giving your developers direct access onto Spinnaker, you don't want to be bringing it down for them, right? Because they can't run their deployments or manage their applications. And finally, you need to understand exactly how the different provider implementations in Spinnaker that you're going to be using actually interface with those downstream providers, because this is going to greatly impact how you can scale and manage performance of Spinnaker itself. So here's where we're going to deviate into kind of a quick expert section of Spinnaker. So I'll ask, is anyone here running Spinnaker at their companies? All right, so some. So scaling concerns as you start bringing Spinnaker up. If you're talking about something like target scale, not all provider implementations in Spinnaker are built the same. So you can easily run into problems where, depending on the implementation, you could run into things like API rate limit problems, or even overloading the downstream provider APIs. Right? So you want to look at how you're tuning some of those polling intervals. If you can do caching of APIs and things like that, the AWS implementation in Spinnaker has something called ETA that lets you cache API calls. Also, make sure you have enough memory to run things. Because Spinnaker is collecting data about your infrastructure, it has to collect the current state of all your deployments before it can flush it into its cache to do queries. So you need to have that room to get data as you're scaling out. And finally, by default, Spinnaker uses Redis as a caching agent for most of its components, and Redis is single-threaded. So at any time, only one thing can be reading and writing from Redis. What you can do, though, is make every Spinnaker component use a different Redis instance. And Redis instances are cheap. Any cloud provider you're going to be using has managed Redis or something compatible. And just from day one, just deploy a Redis instance for each thing. Don't fall into the trap of using a single Redis. It also has some more advanced concepts where you can manage sharding mechanisms inside of Spinnaker itself by application or origin or user, so that you can scale different parts of the componentry. So Spinnaker deployment at target looks something like this. There's a component inside of Spinnaker that's called Cloud Driver that's responsible for talking to the downstream provider APIs. And we run those in both a read-write, and a read-only mode. So we have one fleet of Cloud Drivers that can make the mutate operations into our infrastructure, and we have another fleet that is just purely responsible for gathering the current state of that infrastructure back. Those Cloud Driver implementations talk to fleets of read-write Redis instances that are replicating their data to read-only instances of Redis, so we can manage that. And in between the two, we actually run an open source application called 2M Proxy that allows us to shard data across multiple Redis instances, so we can kind of get that feel of a multi-threaded Redis instance, even though it's single-threaded. And this whole thing is automated and configured in such a way that if we even need to bring up a whole new Spinnaker installation in order to support something, we can do that at effectively the press of a button. So in the end, we ended up with a topology or an installation of Spinnaker that has multiple scaling dimensions, right? We can scale everywhere from the cache up to the individual Spinnaker components and then Spinnaker installations themselves. And we can adjust the right knob for whatever performance problem we're seeing, or if we've just suddenly increased load or scale on something. And this ended up being a really good process for us, because we did run into situations where before we had this topology, we would run into some type of scale-induced thing, and we wouldn't be able to adjust correctly. So that's where we are in our private data center and our public cloud usage right now. Most of our app teams are using Spinnaker to deploy to VM-based workloads. Some of them are using Spinnaker to deploy to Kubernetes-based workloads. But we are starting to see a little bit of a divergence here, where a lot of app teams just want to, if they're on Kubernetes, they just want to talk Kubernetes, right? They want to use kubectl, they want to use Helm, they want to go straight to that cluster, and they want to use native Kubernetes capabilities across there. So we've gotten a bit of a divergence there happening. And as we talk about Kubernetes, I'd be remiss if I didn't talk about Target stores. So not only do we have private data center and public cloud, but Target has 1,800 stores across the United States. And in each one of these stores and distribution centers, we run a Kubernetes cluster. So, but because of the distribution of these stores and these distribution centers, and the connectivity that we have with them, we have to treat them as though they're completely isolated cloud environments from our perspective. We can't be backhauling data from them all the way back to Minneapolis all the time, right? So effectively, we have 1,800 cloud providers that we have to deal with at any given time. So how do we manage this? How do we manage rolling software out to 1,800 disparate clouds? So the first thing that we do is we group our stores into kind of groupings and environments based on things like geography or size of the store or features or technology that we have installed in them and things like that. So these environments can consist of anywhere from 1 store to 300 stores. And when we push new software loads out to the stores, we roll them out to these environments in a sort of batch type fashion, right? So if I push to an environment that has 50 stores in it, all 50 stores are going to get that same software load and be running it. If I'm going to roll that back, all 50 of those stores roll back that software. So how does Spinnaker understand this kind of weird grouping thing that we're doing with all these stores? If you probably haven't read the Target blog, but if you had, we recently posted a thing, and it's called Unimatrix. So Unimatrix is a tool that we built in-house to manage our store deployments, and it effectively is a Kubernetes API facade layer. So it presents a Kubernetes compliant API, replica sets and pods, services, config maps, the whole spiel, and it presents those store groupings as namespaces onto that API. So we point our Spinnaker instance at the Unimatrix server running in our data center, and it distributes desired state out to each of the stores in that namespace. And the Unimatrix agent there then applies that state to the local Kubernetes cluster and is responsible for recovering status and sending it back to us. So from Spinnaker's point of view, we have one Kubernetes cluster running for all 1,800 stores. And this allows us to reason about very large-scale deployments in very simple terms for both our developers and any operations and support staff that we have to deal with. It helps us eliminate deployment drift across these store environments. And we're adhering and utilizing open source API specification, which means any of the tooling out there that's built against Kubernetes API, we can continue to use against our store deployments, even though we have 1,800 of them behind the scenes. So what have we learned from running Unimatrix? We've been running this for a while now in our store deployments, and we've learned that abstracting the infrastructure is good, right? It allows us to reduce that complexity and make better decisions about what should be done. That doesn't mean our developers shouldn't interact directly with that API. Many of our stores developers still use kubectl to talk to Unimatrix in order to perform operations in the store's environments. We also needed to start thinking about what really is an application or deployment, right? And so Unimatrix helps us distill that concepts down to what should be running, how is it configured, what's its current state, things like that. And it also kind of taught us that, this microservice thing is really, really good because we can just replace pieces of componentry where we see fit with our opinions or patterns or optimizations that work for us. So that's our current state today at Target. And about 6 months ago, we started working on a new project because our current state is one where we still have many different ways of doing things, right? We're still talking to some Kubernetes clusters directly. We're using Spinnaker in places. We're using Unimatrix for stores, et cetera, right? And we really want to get to this paradigm of there should just be one way of writing and running and deploying an application at Target. And the way that we think about it is the idea of a midnight developer. And Dan Woods, our distinguished engineer, had a good point, had a really good statement of this, is a developer at Target has to be able to build an application in the middle of the night without having to interact with anyone, with no previous knowledge of our platform. If they can't do that, then we've failed as an engineering and as a platform organization, right? And so that's really kind of the guidance of what we've been trying to do over the last 6 months. And so there's kind of 6 main points of how we're designing and building that platform. So first, we have to have a self-service platform, right? Our developers can't be sending emails or issuing pull requests or doing things and waiting for people to get back to them a day later. We have to have a common pattern of usability, right? Regardless of where they're running on the infrastructure, they need to be able to write that application one time. They need to be able to discover the features of that platform. It needs to be highly available so that they can do their job. And the way that we can do that is through applying some strong opinions, but still allowing for flexibility within the infrastructure and the platform itself. And finally, as platform engineers, we need to treat everything as an application. If we're going to be asking our developers to follow these processes or use these opinions or run on this platform, then we better be too. So over the last 6 months, we've been building a new platform called Target Application Platform, or TAP. And it's combining the best pieces of all the different tools and all the different infrastructures that we've dealt with over the last 5 years as we've come along on this journey. We're combining the power of Kubernetes declarative API along with Spinnaker's imperative workflow engine to orchestrate deployments so that we can manage our infrastructure as a ubiquitous experience for our developers, right? And so as part of that, we're moving our developers up the stack. We're getting them up off of those infrastructure APIs so that our infrastructure teams can innovate and move fast and do the things that they need to do in order to make the infrastructure better without impacting the application developers. I recently had a meeting with one of our big development groups, and the director there was explaining that his team is now accounting an actual number of what they refer to as the tech tax on their team. And this tech tax is the time that they're losing building business value because infrastructure teams keep coming and asking them to migrate or do new things by XYZ date for ABC reason, right? And that's really what we want to get rid of, right? We need to stop doing that as an infrastructure organization or as platform developers. We need to allow app developers to focus on building business value and stop worrying about the infrastructure. So we want to reduce that cognitive load, that write once, run anywhere. I shouldn't have to change my application in order to move it from a container-based runtime to a VM-based runtime. I need to make sure that my workloads are deploying consistently regardless of where they are in the infrastructure. And I need my infrastructure teams to be able to do their job by upgrading clusters or innovating new technologies and building things that can span across the entire enterprise. So in order to support this, we've decided to take what we learned from Unimatrix and extend it to all of Target's infrastructure. So we settled on saying all infrastructure at Target when it comes to runtime deployments or workload deployment and running has to be managed via the Kubernetes API. So we talk about all workloads on TAP as though they're a replica set and a pod, regardless of if it's on a Kubernetes cluster or not, right? So we write layers that interface with things like Openstack and then present a Kubernetes compliant API on top of it. This gives us a single unified experience across all of our infrastructure. It also allows us then to deploy a type of intelligent routing layer on top of that infrastructure that Spinnaker talks to do deployments. Now that routing layer, that intelligence engine, can consume data from wherever we want it to in order to make workload placement decisions about your application. It also allows us to do things like, if we want to upgrade a Kubernetes cluster that requires an outage, we can just bring up a new Kubernetes cluster, disable the old one, the existing workloads will continue running, and all new deployments will go to the new cluster. Right, so in order to make this work, if we're going to use the Kubernetes API everywhere, we have to model a concept of what an application is so that it works across all of these things, right? So we have to talk about what we're going to deploy. And since it's Kubernetes, we're going to be deploying Docker containers. So application developers at Target on TAP, during their CI process, build and publish a Docker container. And that's the end of the story. They'll never have to change that. They'll never have to do anything different. They just need to tell us how much CPU and memory they want. They need to tell us what network port they're going to accept traffic on. They need to tell us how do they want their application to roll out, right? What should we do with the old version? How many replicas should we run? And finally, they need to tell us how do we know that your application is healthy at any given time, right? Those are fundamentally the core concepts of knowing of an application. So how do we, if everything's a Docker container and that's what our developers are building, how do we do things like run on Openstack? Well, our layer that sits in front of Openstack then, when it receives a deployment command as a replica set, can call out to our enterprise bakery, which is actually one of the subcomponents of Spinnaker that we've just extracted and are running standalone without the rest of Spinnaker. And so we do a just-in-time bake of a VM image of that Docker container. So we translate that Docker container into a VM deployment and then tell OpenStack to go run that. So we're able to use all of Spinnaker's built-in abilities for modeling container-based deployments. We can use triggering, and we can do all the stuff that we'd want to do, but we can extend it across any infrastructure that we want to bring in. And tomorrow, when one of my developers says, hey, we want to use Nomad or something, we can plug Nomad into this system with very little effort and not impact our application developers. So we could start testing workload deployments on there if we wanted to. We also have to provide a consistent set of runtime primitives to our applications, right? If we were running on Kubernetes and our developers were using config maps and secrets and services and all that stuff via cluster, they'd be locked into the Kubernetes ecosystem and they wouldn't be able to run on something like an OpenStack if they needed to. So we couldn't do that. So we run all of those primitives outside of the cluster-based workloads with things like HashiCorp Console and Vault. We use a global Fabio load balancing layer for this. And all of our workloads that are deployed, regardless of where it is in the infrastructure, gets a routable IP address for this sake. So we're not doing any network overlay. We also provide primitives for logs and metrics and like kind of API proxying things so that we can reason about applications in a very consistent manner. And this allows us to do kind of SRE and support operations across all the applications on tap very readily without having to know specifics about that application. And finally, I mentioned before, when we started playing with Spinnaker, we noticed that a lot of our developers don't use all the capabilities of like a complex pipeline of any kind. And since we've distilled this model of what an application or a deployment is down to these kind of core concepts, we can also kind of encode a best practice of how we're going to roll out an application into our infrastructure. And we can do that synthetically in a way that Spinnaker doesn't need to know the fully materialized pipeline. We can generate it for them based on what they're telling us about the application. So we've written a new application that exists as part of our Spinnaker installation. Spinnaker has a component called front50. It's responsible for storing your pipeline metadata. So we wrote an application called back40, and it synthetically generates pipeline information based on application metadata. It also allows us to, if we need to, inject in a fully materialized pipeline for Spinnaker. So if we need to build some type of complex workflow, we can do that. Right? And this allows us to kind of manage best practices for deployments across the whole enterprise without having to go to developers and ask them to, hey, go modify these pipelines, right? So that is kind of the target of the future of where we're going, right? And it's been a long journey to get there, right? Long in a sense, but in the last 5 years, we've tried a lot of different things. Right? We've experimented with a lot of tools and patterns. We've learned a lot about what our developers want to do and what they really need to do. And we've fine-tuned what we treat as an application or a deployment or a workload at target so that we can reason about the scale a lot easier. So before I go, just my final thoughts on all of this. If you're not doing immutable infrastructure yet, you should probably start. It gives you a real solid foundation for building consistent deployment and operations patterns for your organization. And Spinnaker really will help you drive that type of adoption if you aren't doing it yet. and it provides many of the best practices, so you don't need to create them yourself. If you're building a platform for yourself or if you're looking to customize these tools, don't be afraid to shape your usage with flexible opinions. Your developers are always going to ask for all the things, but managing scale is a lot easier when you have opinionated patterns of how your developers can use those tools. Right? And Spinnaker will help you model a lot of those cloud providers in a consistent set of primitives and how we're going to talk about an application or how we're going to talk about a deployment. And finally, don't be afraid to customize, right? This is really the power of why we went from, big conjoined applications into microservices, right? That are responsible for singular things, right? Using open source tooling gives you a lot of productivity, but don't be afraid to customize that tooling for your specific needs if it makes sense to. Right? And in this case, Spinnaker's design and architecture will allow you to give you a default installation out of the box with all the goodness, but then you can piecemeal things if you need to, or take them and run them completely on their own in a standalone environment. So I hope what I was talking about today was interesting to you. I hope you have the great rest of the conference, and thank you very much.